Hey everyone, this is my first video that I'm uploading, so please be gentle with your comments. Just wanted to do a quick attack scenario that I created with a recent demo I did with a customer. The two main things that I really wanted to highlight here was how easy it was to misconfigure your cloud environment and in turn to exploit it, and also how important it is to make sure we're reducing the risk exposure by preventing these misconfigurations before they can be exploited by shifting security left, which is another buzz term used in the industry, basically saying make sure your DevOps teams have some automated protection mechanisms in place before they can actually push the button and deploy applications and infrastructures. For my initial foothold into the environment, I'm using a Log4j vulnerable web application that is part of a proof of concept I found on GitHub, which I'll share the link below. I'm deploying the application on a Docker container into my AWS account, and on my screen I have logged in using SSH to both my adversary Kali Linux machine and the victim web server, which is running the standard Amazon AMI. Starting on my Kali machine, if I list the contents of the proof of concept directory, we can see everything I cloned from the GitHub repo, including the exploit itself, the web application, as well as the JDK binaries and a policy.json file that I created, which I'll talk about in a few minutes. I'm just going to open up a tmux session so that I can quickly create and move between multiple tabs in my Kali machine. And I'm going to set up a netcat listener on port 9001, which will receive the reverse shell from the web server. And then I'm going to create another tab with Control plus B, then hitting C. On the new tab, I'm running the Python exploit. The user IP here is my Kali machine. The exploit also creates a listener that acts as a web server on port 8000, which deploys the exploit.class file, which has the instructions to connect to port 9001, where the netcat listener is listening. The last step of the exploit is that it's creating a fake LDAP server, listening for the incoming connection from the vulnerable application. The Log4j vulnerability in a nutshell allows the application to make an LDAP request without any sort of user authentication, and that's exactly what we're doing here. I'll share more detailed information about the Log4j below as well. Once we have the exploit and the listener ready, we can run the exploit. And first, I'm just going to move to my victim web server and run the application. You can see that I'm running the container here in a privilege mode, which is never a good idea unless you absolutely have to. A privileged container has access to the underlying host and allows to easily escape the containerized environment. In the real world, I've seen developers that are either still developing the application and want to be able to have privileged access from within the container for debugging and development purposes, or more junior developers that are either lazy or don't fully understand the implications of it. Also, just a quick note that I'm exposing port 80 in a bridge networking mode, which allows access to the container through the host network interface, which is a very common thing for web applications. Now that the application is running, let's verify that I can access it and that it's in fact up and running. Just going to copy and paste the URL into Chrome, and here we go. We can see the application is running and awaiting user input for authentication. All I have to do now to exploit the application is to paste the string that is going to exploit the vulnerability and tell the application to make an LDAP request to my adversary machine, which will trigger the reverse shell. We can see that my fake LDAP server received the connection on port 1389, and it directed the request to the web server, which was deployed on port 8000 to deliver the actual exploit. If I move to my first tab, where my netcat listener is, we can see the connection has been made, and we now have a reverse shell. I'll just set up the term variable just so I can clear the screen and make it a bit easier for everybody to see. And then we're going to run who am I, and we can see that I'm root, which again is bad practice, but unfortunately happens all the time. I'll run the uname command to get the kernel information, which shows me the host name I can see with the kernel that I'm running on Amazon AMI. The host name as well gives me a pretty good indication that this is a container or at least an automated deployment of some sort because it's a randomized string. If I run the ps command, I can further verify that this is a container just by seeing that there's only 3 processes running, which if this was a full-blown operating system running a web server, there'll be much more than just 3 processes, obviously. I'll quickly clear the screen, and now this is where the fun stuff begins. Because the container is privileged, if I run fdisk -l, I can see that I can actually mount the underlying host file system into the container. I'm just grabbing for the /dev to simplify the output, and I'll create a directory called hostfs in /temp, and I'll mount the file system there. Now, if I change into that directory, anything under this directory is from the host itself, and I'm running as root. So now I have root access to every file on the victim web server, no longer confined to the container environment. This allows me to do several things. For example, I can cat the password file and see all the users. I can also cat the shadow file. Again, I'm the root user, just really confirming that I can see the EC2 user account. And as I mentioned in the beginning, I really wanted to highlight some common cloud misconfigurations. So if I query the EC2 instance metadata to check if there's any IAM roles assigned to the machine, I can see that the instance has a role called S3 admin role to it. The default settings now allow me to query that role specifically, which actually shows me the access key ID and the secret. So now I have access to this role independent of this specific instance. I obviously blurred out the actual key and secret here, and will blur out some more critical information going forward. Furthermore, because I have root access to the file system, I can manipulate the SSH authorized keys file and make sure I can access this instance directly with SSH now as the attacker. This is the authorized keys file now. I'll just create another tab in my tmux session and generate a key pair on my Kali machine. I'll call it Jack and save it to the local exploit folder. And now I can cat my public key, I can copy it. I'll move back to my reverse shell, and here I'll just use the echo command to paste it and append it to the end of the authorized keys file. Now if I clear the screen and cat the file again, we can see that I have 2 public keys there now. If I move back to the previous tab and clear the screen, I can now directly SSH into that instance as the EC2 user and with the private key I created. This would be extremely difficult from a defensive perspective to detect, as it's just a normal EC2 SSH connection. To go further and show how I can manipulate some of the control plane of my AWS environment, I can use the role assigned to this instance to query all S3 buckets in this account using the AWS CLI. In this case, we have 4 buckets listed in the account. We can set the bucket policy on one of them to remove the restrictions that block public access. And if you recall, I had that policy.json file I created previously. I'll just create another tab. I'll copy that file into this instance using SCP. I'll just open up the file using Vim to show you that it's allowing read access to everyone with no authentication required. All I have to do now is to apply that policy to the bucket, and all the files that are in that bucket are now publicly available, and the adversary can start exfiltrating data out of our organization. It's really important for me to say at this stage that there's definitely a lot of ways to block these attacks, and a lot of organizations are doing amazing work securing the cloud environments, but it only takes one mistake sometime to let someone in and give him the keys to your kingdom or your crown jewels. Even the best developers I've seen sometimes don't really understand security and how important that is. There's also a lot of organizations that are just starting their cloud journeys and are unaware of how easy it is to misconfigure your environment and lack of understanding of the shared responsibility model. In a nutshell, Make sure you have tools and processes in place to verify and protect your applications, your environment, and your users. A good CI/CD pipeline would have not allowed that application with the Log4j vulnerability to be deployed. A good cloud posture management tool would have alerted us and help us remediate against unauthenticated users accessing the metadata on the host, and more. Just a couple of examples. Honestly, I can talk about this for hours. I'll stop it here, and please feel free to reach out to me if you have any comments, feedback, or concerns, and I'll gladly talk about this in more detail and open to any kind of ideas and suggestions. Thanks very much for watching the video. Would appreciate if you like it.